We all know that plants interact with light. They need it for photosynthesis together with water and various nutrients in order to obtain sugars. And this process fits the world, as the carrots and salads we enjoy eating are a consequence of this. Besides using light for this purpose, plants can also reflect it, and they reflect it within different parts of the spectrum. For example, when you take a picture of a sunflower, you're capturing the visible wavelengths that it is reflecting. However, plants interact with light all throughout the spectrum, not only at the visible parts. But wait, why are we interested in this? Understanding the reflectance patterns of plants allows understanding its condition. Is it growing well? Is it well irrigated or fertilized? Satellite remote sensing allows covering large areas, for example croplands, providing imagery at several wavelengths. It is a combination of imaging and spectroscopy. The openly accessible Sentinel-2 satellites, launched by the European Union, offers an improved resolution and opportunities for agricultural monitoring. My PhD thesis focuses on Spanish cereal agrosystems in the Iberian Peninsula, using remote sensing and geographic information systems. We are interested in studying the spatial interaction of wheat genotypes with environment at various agroclimates. We want to determine the most suitable genotypes and locations for wheat farming regarding grain yield and the quality of the grain. But wait, that is the idea. Is it an adequate approach for this aim? As of now, we have studied Spanish northern region with promising results. First, we have developed a grain yield model with Sentinel-2 and actual ground data on crop performance. This followed with a crop type classification of the region, as we wanted to map the wheat growing sites. After a totally classified wheat fields, the grain yield estimation model that we developed first was applied, resulting in a map of wheat grain yield distribution. By studying the spatial gradients of grain yield, we found out that rainfall and topography had a strong impact on it. This approach resulted in a precise mapping of wheat and grain yield estimation compared to the official statistics. And also it allowed determining the most suitable locations for wheat farming at that northern region. Now I'm moving forward into studying grain quality with this approach in this region. And we are also preparing spring field work in Middle Spain.